Hey everyone, great to be here in Orlando. I spent a lot of time on this demo, so I'm happy to be the one to talk about what went into the 5.6 release. An open world like that was just the perfect content to focus on our main goal for the release, which was performance. We want the engine to scale to large and rich worlds. We want to preserve graphics quality. And of course, we want to deliver high frame rates that you and your players expect. So let's check it out, starting with rendering. If you all remember, when we released Nanite with UE5, it supported static geometry. Last year, we brought skinning to Nanite. And now, we're working on Nanite foliage. The only way to have a forest that looks as good as this one is to use 3D geometry for all parts of the trees, just like we do for everything else. However, this is a crazy amount of fine geometry, so we had to rethink how trees are created and displayed. To create them, we developed Nanite assemblies. These 28 little parts that you see are all that we use to build all the spruces from the forest. They are instanced thousands of times and used like building blocks to assemble trees in different ways. And as you probably noticed with the wind effect, they even support skeletal animation, which runs on the GPU. Thanks to assembly, we greatly reduce the storage, the runtime memory, and the rendering cost. Then, to display an entire forest, the challenge was to preserve fidelity and performance from any distance. Let's check up close the level of detail we're talking about here. Lots of details. But this triangle representation is not the most efficient when far away, due to the amount of overlapping. And that's why we made an adaptive voxel representation. But in reality, you'll never see those voxels this close, since when we move the camera back, they're barely a pixel. Nanite foliage is almost done. We are moving it to the main line as we speak, and it will be available for everyone in 5.7. Another thing I would like to share is that ray tracing and Lumen now run more than twice as fast, with no visual trade-off compared to when UE5 was released. And because of that, we can now hit 60 FPS on consoles. And finally, we rewrote the rendering pipeline to run asynchronously so you can increase the richness of your scenes even more. Now let's talk about chaos physics. For chaos cloth, we improve our cloth-to-cloth constraint solution. This removes a lot of collision evaluation when garments are piling up and interacting with each other. Even for complex setup like Ciri's cape, we hit a sub-millisecond budget on PS5. With Chaos Flesh, we introduce procedural muscle activations to make deformation and motion more natural. Your artist will still have control over tetrahedral simulation and train ML models that run fast in real time. We now support the baking of fluid surface data into lightweight assets to be played back at low cost. This is going to give you high-fidelity water without the performance cost of real-time fluid simulation. For animation, we work on both performance and fidelity. Here, you can see how Ciri and Kelpi match up in their interaction. Well, that works no matter the angle of approach. That's our Molds character motion matching solution. We also added motion matching in Sequencer to build stitch tracks. With them, you can seamlessly transition from gameplay to cinematic. Also, we now have a secondary layer of animation driven by physics in Control Rig. We used it in Kelpi's rig to drive the mane, the tail, and the saddlebacks. And now, I'm happy to announce that all these features are already integrated into our new Unreal Animation framework, which we are releasing as experimental in 5.6. We built it with performance first in mind. Animation evaluation are now running in parallel off the game thread, which was our bottleneck. And for the other character systems that are just as costly, like movement, avoidance, state tree behaviors, we also move them to worker threads. This is really going to help you create scenes that are crowded and lively. Streaming has always been a big deal regarding performance. And the three biggest improvements we made are physics state creation, which now runs async, improve runtime PCG for ground scatter on GPU, and a new FastGeo plugin to stream static geometry. And just to take a different example, in CitySample, the streaming time was cut down by 90% while moving at high speed. We focus on a lot of areas for performance in 5.6, and mobile is no exception. We work on better defaults and scalability settings for mobile and minimize the default package size. We also improve our workflows with a UI refactor of the viewport toolbar and content browser, an on-device iteration workflow, and a mobile preview solution. So there you go. Unreal Engine 5.6 is all about performance, and it's available today. Please go enjoy the tech talks and session we have for you guys and come chat with us. And now, please welcome Chris from the MetaHuman team. Thank you.